Lennon has to get on at 11. So do you want me to tell him?
Yeah. Can anybody hear me right now? Anybody at all? Okay. All right, good. So Jack can hear me. I'm assuming Paloma, can you hear me? And can you see the screen? Man, I'm getting old, folks. All right. So allow me a moment for those of you that can hear me. I know that this is kind of wonky right now. It's going to get better. It'll be much easier to sign on. We're going to have the live chat on the website from now on, so you guys can log on, and I'll be available all day long for your convenience. So you can log on to that chat that you just logged into all day. The button will be there in a different place, but it'll be there. So if you have questions, if you have an issue, you can just log on to the chat and I'll be there. Just give me a minute to answer. If I don't answer right away, it's because I'm not looking at the screen. What I want to talk about a little bit, most of you got the scientific notation pretty much down pat. But a couple of you are just missing a couple things. Let's see here. If some people just logged in. All right. Oh, Curvich is here. Jack's here. Man, we got a bunch of people, man. This is great. Let's go. Who is Bowser for? Oh, that's got to be Jack Bowser, of course. I should have known. Okay. Scientific notation, right? Hopefully you guys can see this. If I have a number, and it'd be good if this thing actually worked. Oh, come on. What are you doing? Huh. All right, let's try this. All right, there we go. So if I have a number 54,000, okay, all scientific notation is, and most of you got this right, but all scientific notation is I'm moving this decimal point to the place where, I lost my screen here. Hold on. Okay, should see it now. If I have a number like that, okay, what's up, Curvich? All I'm doing to get scientific notation is moving the decimal point to the place where I only have one number to the left of the decimal, right there. And then all I'm doing is counting how many places I moved it. 1, 2, 3, 4. I moved it 4 places, right? So my scientific notation is what? Times 10 to the power of 4, right? Every time that's how it works. Times 10 to the power of 4. That's it. It's very, and if you have this, if I'm asking you for standard notation, right? And I'm giving you this instead, all you have to do is say, okay, it's to the power of 4. So all I need to do is take my 5.4 and move my decimal point back over 4 places, and I get 54,000. That's it. Right? Does anybody not understand that? Brandy's not a student. What is she doing here? Okay, so everybody gets that, right? Okay. Does anybody not have their math books? Yeah, I know it's Jack. You have your math book, Jack? Or you don't have it? You don't have it. Okay, hold on a second. Okay. If you don't have a math book, that's okay. Just do me a favor and get out a piece of paper and something to write with. I want to review we were working with multiplying and dividing like bases. Well, actually, let's just review real quick the adding and subtracting like terms. Okay. If I have something like 2x plus 3x plus 5, okay, my like terms in this particular situation are pretty obvious, right? 2x and 3x. When I'm adding, I can simply add these terms together and I get 5x plus 5, right? Let's look at a different one. If I'm doing 7b to the third power plus 4b to the second power minus 10b to the second power minus 4b. Okay. Don't get confused. Don't let it, I know it looks like a lot of numbers, and it is. What I want you to do is I want you to see this for what it is. Okay, what I mean by that is I know typically one way we look at this is a string of operations. And I don't, for these purposes, that's not the way we want to look. What we want to do is we want to separate these. Okay. And we want to add signs where there is none. So it's positive 7b to the third power, positive 4b to the second power, negative 10b to the second power, and negative 4b. Okay. And what we're essentially doing is we're saying if we put all these different numbers in a box and shook them up, what's the product, right? If we put them all together, given their signs, what do we get at the end, right? And the reason I say that is because when we're adding, or in this case, when we're adding like terms and they're negative numbers, we need to take that into account, right? There is no like term for 7b to the third power. There's no other term here that qualifies as a like term with this number. So we know that we can just rewrite this. If there's no other number with this same exponent, then there's nothing we can do there. That's going to be a number by itself, and I do not want a brush size that big. So, wow, that is gigantic. Modern technology, folks. 7b to the third power is by itself, and it's positive, right? Then we have 4b to the second power minus 10b to the second power, right? Now, positive 4b to the second power and 10b to the second power are like terms, right? Same variable, same exponent. Problem is one of them is positive and one of them is negative, right? This right here. These are like. They have the same variable, same exponent. Same variable, same exponent. This number doesn't matter. If this number is different, no big deal. The like terms means that the variable and exponents are the same. So we have a positive 4b to the second power and a negative 10b to the second power. Another way to say this is positive 4b to the second power minus 10b to the second power, which is going to give us negative 6b to the second power, right? 4 minus 10 is negative 6. So 7b to the third power minus 6b to the second power. And then what about this 4b? There's no other like term. It doesn't have an exponent, so it doesn't qualify with these two, right? So it's just off by itself, minus 4b. And that's how you simplify that. I know it sounds complicated. It's really not. Once you get the hang of it, it's actually fairly simple. So let's look at another one. Let's say 7b to the second power plus 3b minus 4b to the third power. Do I have any like terms here? No. No, we're just doing problems on the screen. I just want you to understand like terms. What are the like terms here? Are there any like terms? What are they, if they are there? Do any of them have the same exponent? They don't have the same exponent. So since they don't have the same exponent, they're not like terms. There are no like terms here. So there's nothing for us to combine. If they don't have the same exponent and the same variable, then they can't be combined as like terms. All right. Okay, let's do this real quick. I'm going to give you some problems. You're going to tell me. Hold on a second, folks. I got to get my son logged on to this. All right, you got 9A plus 9B. You're gonna have to sit right there, and unless you're gonna have to keep your mic muted pretty much the whole time, unless you really need to say something.
Yes. I mean, sir.
Yeah, I'm not a man. I'm a dude.
What is this subject?
It's math. Sorry, folks. Give me 1 second. I got children in need of attention. 9A plus 9B. Are those like or unlike? And I can't see your answers, but if you said unlike, then you have won the prize. I'm not sure what that prize is going to be, but here.
Can she see me? Are you?
No. Talk. All right. So let's see. Unlike. Right? Jack got the prize. I'll tell you what the prize is later. Don't hold your breath. Unlike, right? What about negative 5x plus 10x? That doesn't look like a 5 at all. I don't know how you guys learn anything with my drawing skills. I'm such a talented artist. Are they like or unlike? Negative 5x. Do they have the same variable? Yeah, they're like. Right? They have the same variables. I'm trying to draw on the wrong screen. Man, I am a genius, let me tell you. Same variables, right? So they're like, don't worry about the negative or positive. This means nothing. It doesn't matter if you have a negative or positive number, as long as they have the same variables and exponents. And also remember, if you were to say, well, so if I have a negative 5x plus 10x, the negative sign doesn't matter. You're looking for variable and exponent. And what is the understood exponent of a number that doesn't have an exponent listed? It's 1. So they both have the same exponent. So essentially you're looking at 5x to the power of 1 plus 10x to the power of 1. These are like terms, right? Okay. If I wanted to simplify, Landon, what are you doing? If your video's off, right?
Yeah.
You just left the meeting.
Oh.
Dude, that's why I wanted you to sit. Why did you need to leave? Because she asked you a question.
Oh, I didn't want to interrupt your talking. Or talking.
You're good. You can still talk out here.
Do I have to have the video off?
Yeah. And look, if you're not saying nothing, just mute it. All right. Sorry about that. Children, no, look, I lost my screen again. Oh, this is just working beautifully, isn't it? Okay, we're back. Anyway. All right. If I have 9z minus 3z, what is that simplified? Nine z minus 3z is 6z. Simple as that, right? Very simple. Everybody understand? Okay. If I have is this simplified or not simplified? Can I simplify that further? 8x plus 4x. It's not simplified. What's the simplified form of that? $12x. How about 16? Well, I got to get to the right page. How about 16 minus 4r plus 2? Let me see if I can write this a little bit better. (16) minus 4r plus 2. Simplified or not simplified?
Divided by 6 times 3.
What do you guys think? Okay, what would it be simplified if it's not simplified? The not. The not. It is the not. That's the answer. 14R2. So can I rearrange? Can I say 16 minus 2 plus 4r?
You have to do the 2 squared to make it.
Can I do that?
4.
Now let's look at it. Okay. If I do that,
4.
okay, 16 minus 2 is 14, right? Plus 4r. If r equals 1, 14 plus 4 is 18, right? Let's use our original problem and see if we get the same answer. If r equals 1, 16 minus 4 is what? 12. Plus 2 is 14. So we have a problem. We didn't get the same answer. If you don't understand what I'm talking about, let's look at it a different way. 16 minus 4r plus 2. Remember when I said that we have to separate these? Wow. That is not going to work. This is positive 16. This is negative 4r. Positive 2. I can't make this a negative. So if I were to rewrite it, 16 minus 2 plus 4r, I'm making this a negative and I'm making this a positive. I can't do that. I mean, I can do that, but I'm going to get the wrong answer, right? So what I need to do is rewrite it a different way. It needs to be 16 plus 2 minus 4r. I need to retain the signs of the original numbers. It's negative 4r and positive 2. That needs to be the same here.
I will ask. She wants to know if you're in a different room so that she doesn't hear you.
We don't have a different room.
The bedroom or no?
Hold on, guys. Just mute your mic, dude. You don't have to talk the whole time.
But she's asking us questions we all have to answer.
Just go in the room, make sure your video stays off. Jeez. All right. And make sure Braden has his sound off. All right. Does everybody understand what I just said? When you're looking at a problem like that, you have to, if I were to, let's look at another one. 18p plus 4 plus 6p. Okay. Is that simplified or not simplified? She is behind. It's not simplified. So how would I simplify this? You just add, right? Just add the 18p plus the 6p, right? Now, here's where it gets kind of tricky. Okay. So bear with me on this. When we're adding like terms with exponents, okay, if we have 13w to the third power minus 6w to the third power, what is this simplified? (13w to the third power minus 6w to the third power). You would think so, right? You would think that it would be 6 or, well, what's 13 minus 6? 7, right, Jack? So you would think that it would be 7w to the power of 6, but it's not. It's not. It's 7w to the power of 3. You don't add these. You carry over the like exponent. You don't add them. When you're adding exponents, it's all right, Jack. Don't cry. There's no crying in baseball, man. When you're adding or subtracting exponents or numbers with exponents, you don't add the exponents. Relax, Curvage. Calm down. All right, I'm going to give you some problems. And So if you can read this, the first one is 7W plus 3W. So you should write these down. Second one is 8W to the second power minus 3W. Third is 4W to the third power plus 3 minus 6W to the third power. Fourth is 3W to the eighth power plus 3W to the eighth power. And the fifth one is 6W to the second power minus 3 plus 4W. I want you guys to do that on a sheet of paper. And then I need you to take a picture of the answers and upload it when you get done. So I'll give you about 5 minutes, and then we'll continue on to something else. Yeah, whatever you got to do. If you want to type it into a note or whatever, can't you screenshot on an iPad? Yeah, that's right. Everyone like and subscribe, because we're gonna grow this channel, folks. We're gonna dominate the world. I'm just joking. Gonna be math geniuses. Time's running out. Now we're gonna move on to what's up?
Can I take this?
All right. So there's the problems again. If you haven't gotten them all, you can do them later. We will move on to something else. I'll have a picture uploaded of this. Let me. I'll have a picture uploaded of this to the website. So if you missed it, then you'll be good to go. All right. Now we're going to talk about multiplying like terms. This is a little bit different, but somewhat the same, which doesn't make any sense, but it will in a minute. Okay. If I'm multiplying like terms, y times y times y to the third power, what is the simplified form of this? This is going to be a 40-minute. Yeah, I know. We got to make sure you're smart, Curvich. You need to go away from this knowing stuff. Curvich, you're a trip, man. Curvich said, dude, this is a 40-minute lesson. All right, what is the simplified form of this, Curvich? Y to the fifth power, right? Because remember that these have unstated exponents of 1. So when you're multiplying like terms, you add the exponents. You add the exponents, right? If I have x1 times x5 times, I could probably use a different thing here, so considering it's x. Let's do y. So y1 times y4 times y8. That's an 8, I promise. There it is. This thing is hard to draw with, man. What's the simplified form of that? Fifth power. It's an 8 at the end. What text? So I'm not looking at my phone right now. Why do it's 8 plus 4 plus 1. I'm not looking at my phone right now, Jack. Y to the 13th power. All right. Let's see, we did scientific notation, chapter 10 review. All right. If you don't have a book, what I'm going to do is I'm going to upload page 416 and 417, which is going to be multiplying and dividing monomials. So, okay, that's fine. I don't speak Japanese. So, and what I want you to do is I'll upload all the pages. I want you to do homework 10.4. So multiplying monomials. A monomial is an algebraic expression that has one term. To multiply a monomial by a monomial, multiply the numerical coefficients and then the variables. When multiplying variables, remember to follow the rule for multiplying like bases. Add the exponents. Just real quick, and then we'll get you out of here because I know you have fun stuff to do while you're supposed to be at school. 3a to the second power times b. And 2 times a times c to the second power. I'm probably going to have to make a video on this. I I tell you what I want you to do is I want you to start working through page 416. I'm going to upload it. Some of you are going to struggle with this. I want you to, the steps to this, are to multiply the numerical coefficients together. The second step is add the exponents of each like base. Who remembers what a coefficient is? So this, if we were to rewrite this, I don't want to do that. So 3 times A to the second power times B times 2 times A times C to the second power, right? So essentially you have some like terms here. You have the A to the second power. And then you have another A over here, right? So you could essentially write three times 2A to the second power plus 1 times B times C to the second power. And what you're doing, it'll eventually be, the final answer will be 6A to the third power times B times C to the second power. That would be the simplified form of this. And essentially all you're doing is you're adding the exponents. So 6A to the third power times B times C to the second power is taking the exponents, for A. Remember that A has an understood exponent of 1, right? C has an exponent of 2. That's where you're getting the 2 here, the C to the second power. And you're essentially just rearranging things and adding like terms. So if we did this a little bit different, I know I probably just totally lost you. Let's slow it down, and then we'll get out of here. 3A to the second power B 2AC. Okay. Multiply the numerical coefficients together. What are the coefficients in this problem? What are the coefficients? Anybody know what the coefficients are? The coefficients are 3 and 2. Okay? Those are the coefficients. They're the numbers that we multiply the variables by. So if the first step is telling us to multiply the coefficients, then that's what we're going to do. 3 times 2. Okay? And then it's telling us to add the exponents of each like base. So what like bases do we have here? Is a to the second power and a to the first power a like base? Look at the problem. If you don't get this, you're going to get lost later. This right here. Oh. That right there. And this right here. These are the same variable. So you have a to the second power and a to the first power. So I can rewrite this as a to the second power plus 1, right? Because I'm just taking these two. I'm doing what it says. You're adding the exponents of like with like bases. What's the other one? I have b to the first power and c to the second power. B times c to the second power. I don't even have to write the 1, but there it is. This isn't like a like term with anything, so I know it's going to remain the same. B, c to the second power. This can be rewritten 3 times 2 is 6, right? 6a to the third power. Does anybody not understand what I just... If you don't understand, you got to tell me, because you're going to get lost. Does anybody not understand what just happened? You do understand. Let's look at one more. I'm about to tell you. One more, and then I'll give you your assignment. Two xy to the second power times 3x2 times y to 5xy. All right. What I want you to do with these problems is I want you to separate the coefficients. What are the coefficients? My coefficients are 2, 3, and 5. Right? 2 times 3 times 5. Then on this last number, you have to now start the string of multiplication that's going to take care of your variables and exponents. So what you have is you want to start with alphabetical order, x, and then you'll go to y in a minute. So it's going to be 5x, and then you're going to add your x exponents. You have 1, 2, and 1. Plus 2, plus 1. So essentially x to the power of 4. Right? Times y. And then you do the same thing. 2 plus 2 plus 1. 2 plus 2 plus the unstated 1. Right? And then you multiply. 2 times 3 is 6. 6 times 5 is 30. Right? X, 4, Y, 5. 30x to the 4th power times y to the 5th power. If you don't understand what I just did, you need to talk to me. All right? That's how you simplify these. So what I want you to do is I want you to read this over. I want you to do practice 10.4 on page 417, 1 through 21. And if you don't have the book, I'll upload it right now. All right? Any questions? You do have my phone number. The chat will also be open. So you can come talk to me anytime you want. All right? Any questions? All right, and this video will be for uploaded as well for you to rewatch if you feel like it. Okay, and so what we're gonna do is we will have. I'm not doing 8th grade math because there's nobody that's registered in 8th grade math right now, so that's not going to happen. So we'll do another stream at 1 o'clock, and that'll be for science, I believe. And then 2 o'clock will be history. All right. Be there or be square. I should make an RPG game. Yeah, in my spare time, I'll go ahead and put that together. All right. You guys have fun.